Today we're exploring real numbers. Natural numbers are numbers as we know them since kindergarten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they go on. Whole numbers include the number 0. So we start with whole numbers 0, 1, 2, 3, 4, 5, 6, and they continue. Integers include all the negative numbers, 0, and all the positive numbers. If you look at the back of the classroom, I have a number line, and look at its heading, integers. Positive to the right side and negative to the left side of the 0. Do you see that? Those are all our integers. Now, rational numbers are any numbers that can be written in the form of a over b, where a and b are integers. What does that mean? That a and b can be negative 1, negative 2, negative 1, 0, 1, 2, 3. Any negative, any positive number. When a rational number is written in the form of a decimal, when it's written in the form of a decimal, it is terminating, which means that the decimal ends. So if it's a terminating decimal, for example, 2.5, does that decimal end right there? 6.27, terminating, it ends. Or it's repeating. What does it mean to be repeating? For example, here, 8.22222, and the 2's go on forever. Can also be written as 8.2 with the bar on top of it. Another example of a repeating decimal would be 0.3, which can be written with a bar. That the 3's repeat. Any decimal where the numbers repeat without end would be considered rational. So let's try some examples. If we need to classify the number, we have to name the set of numbers to which each number belongs. So we have negative 17 over 31. Would negative 17 over 31 be a natural number? A whole number? An integer? An integer. It's a rational number. Why is this a rational number? It's written in the form of a over b. If we change this fraction to a decimal, it either terminates or repeats. Can somebody change this to a decimal? Let's say we have the number 23. Is the number 23 a natural number? Yes. Yes. So this is natural. Is it a whole number? Yes. Let's look at the whole numbers again. Yes. Is it an integer? Yes. Is it rational? It's rational also. It's rational because if we want to write 23 in the form a over b, we can say 23 is equal to 23 over 1. If we want to write 23 as a decimal, it means 23.0, and it's a terminating decimal. So the number 23 is natural, whole, an integer, and rational. Yes, ma'am, you have a question? What about the number 0? Is the number 0 a natural number? Not natural. Is it a whole number? Yes. Yes. Is it an integer? Yes. Therefore, is it a rational number? Yes. What about the decimal point 4.581? Is this a natural number? No. A whole number? An integer? No. Is this a rational? How do I know it's a rational? It's a decimal that terminates, right? That was one of the requirements. It's a terminating decimal. Can I write this as a fraction? Yes. As a mixed number, what would this be? 4 and 10 hundredths thousands over. Could I change this to a improper fraction? 4,581 over 1,000. So do I have it written as in the form of A over B? Yes. Very good. Rational numbers are numbers that cannot be expressed in the form of A over B. That means it's a number that we cannot write it as a fraction. In its decimal form, it does not terminate and does not repeat. So I have here a few examples. Have you heard of pi? 3.14, and it goes on and on and on and on and on forever, right? Now, we don't know that pi ever ends. Now, we abbreviate it as 3.14, 3.14, and that's how we use it when we're talking mostly about circles. But it's a decimal that does not terminate and does not repeat. For example, the square root of 7. If I want to find the square root of 7, the calculator doesn't go on forever, but anytime it's a number under the square root sign or under the radical that is not a perfect square, it is a decimal that does not terminate. So the square root of 7 is equal to 2.6457513111. This goes on. That's why it is irrational. The square root of 2 over 3 is irrational because 2 is not a perfect square and 3 is not a perfect square. And that's why the square root 2 over 3 is also irrational. The set of real numbers is formed together by the rational and irrational numbers. That means that if a number is rational or irrational, they're real numbers. An inequality is a mathematical sentence that includes the value of expressions using an inequality symbol such as less than or greater than or less than or equal to or greater than or equal to. For example, we could say -1 is less than 2, or we can say 5 is greater than 0. If we need to order fractions from least to greatest, then we have -3/8, -1/2, and -5/12. What can we do to order these fractions? Yes. We can change them to have the same denominator. What would be the least common denominator in this case? 24. 8 times what is 24? 3, and 3 times 3 is 9. We keep our negative. 2 times what is 24? So 12 times 1, -2. 12 times what is 24? 2, and 2 times 5 is 10. Keep our negative. Now we can focus on our numerators to order our fractions. What would be the smallest fraction? Look at the -12, and we can take a look at the number line in the back. The farther the number is from 0 to the left, the smaller. So this means the smallest fraction would be 1/2, followed by -5/12, and the largest fraction in this case would be -3/8. Opposite numbers are two numbers that are the same distance from 0 on the number line. So the examples I heard earlier were 2, and negative 2, and 1 and negative 1, and those are good examples. If we draw our number line, and we count the spaces, from 0 to 2, there's 2 spaces, and from 0 to negative 2, there's also 2 spaces. And that's why these are opposite numbers. 1 and negative 1 would also be opposite numbers, and the distance from the number line is also the same. Absolute value is the distance from 0 on the number line. So that means that if we have let's say we want to find the absolute value of negative 3. The distance from 0 to negative 3 on the number line is 1, 2, 3. So the absolute value of negative 3 is 3. What would be the absolute value of 1? 1. The distance from 0 to 1 on the number line is 1. What would be the absolute value of negative 2/3? Positive 2/3. So absolute value is always written as a positive because absolute value measures the distance from 0. So what would be the absolute value of half? Half.